Hello, I'm Eviana Rizki. In this video, I will explain how to teach trigonometry comparisons to blind students. The teaching aid used is a geoboard which consists of a rubber board and also nails. Then there is also the right triangle that we have made. The sides are free, but for the triangles I used, the base side is 8 centimeters and the high side is 6 centimeters. There is also here a correction type that I will use to mark the corners of the triangle. Well, the first one, after we have made a triangle out of a cardboard or other paper that is thick enough so it doesn't fold easily. We will mark this right triangle. In this right triangle, we will make a mark with the correction type. So, in one of the corners, we will put a mark in the form of a raised point on one of the acute angles. We will use this angle as a benchmark and it is called the theta angle. We can use correction type so that one corner is different from another. Well, let's wait until it's dry. Later, a pop-up will appear so that the blind students can touch it. On the geoboard, we will create or position the x-axis and y-axis easily. We can circle the rubber so that on the geoboard there are points that are between the two rubbers. Now, what I have installed is the x-axis. Then I'm going to attach the y-axis so we can move it to the middle. Likewise, on the y-axis we will position a series of points on the board which we will make points on the y-axis. We are moving to the middle. Well, after it's installed, it becomes a Cartesian coordinate consisting of the y-axis and x-axis and also has quadrants 1, quadrants 2, quadrants 3, and quadrants 4. So, if students haven't learned about quadrants or forgot about quadrants, the teacher can remind them again that in Cartesian coordinates have 4 quadrants. Quadrant 1 is in the upper right, then moving to the upper left is quadrant 2, to the lower left is quadrant 3, and the lower right is quadrant 4. Okay, now that we have set the Cartesian coordinates, we can place the right triangle in quadrant 1. So, the base side is parallel to the x-axis and the height side is parallel to the y-axis. After the markers have dried, we can ask students to fill the right triangles. Now, in this right triangle, in the part that has been marked is the angle that we named the theta angle. It means that from the point of view, we will make it a benchmark. So in trigonometry, that is the ratio of one side to the other in a triangle. Now we write the trigonometry comparison first. The first is a trigonometry comparison. There is a sign ratio, or when it is abbreviated, we just write it as sin or SIN. So, to make it easier to remember what the sign ratio is, we can remember that sign has an abbreviation, namely there is a sin O hype. Namely, the sign ratio has a comparison between the opposite O and the hypotenuse hype. So, therefore, we must first understand which is the front side or the opposite side and which is the slanted side. What we use as a benchmark is the fixed angle. Here I also write the symbol in the starting letter. So the theta angle is in the corner which we use as a benchmark. So from the position of the theta angle, if the side is in front of or in the opposite, it means that it is the front side or the opposite side. So here from this triangle, for the front side, this is the height side of the right triangle. This is the opposite side of the theta angle. Now for hypotenuse side of sine or hype, the hypotenuse side are known in a right triangle. The hypotenuse side is the longest side that has the name hypotenuse. Then for the base side of this triangle has the name adjacent side because it is right next to the theta angle. So if I repeat for the high side of the right triangle, it is the front side. Then the hypotenuse means the slanted side of the hypotenuse, and the base side is beside or the base side of the right triangle in the side. So it means that for the sine or hype comparison, if from the formula it looks like this. Sine is equal to the opposite side over hypotenuse side.
Dari rumusnya bentuknya seperti ini. Sin theta sama dengan sisi depan per sisi miring. Nah, di sini untuk memudahkan kita juga untuk mengingatnya, kita bisa posisikan sudut.
Now, to make it easier for us to remember, we can put the position of the right triangles like this.
Dengan nilainya atau dengan dia sejajar dengan sumbu apa. Nah, untuk
then we can name it by its value or by what axis it is aligned with. Now for the side parallel to the x-axis, so we can conclude that the base side in the same direction or parallel to the x-axis for the side. We can name the side x.
Sejajar dengan sumbu x, sehingga untuk sisi samping kita bisa beri nama sisi yang x.
Then for the front side or opposite side, because it parallel to the y-axis, we can name it the y side. Then for the hypotenuse side, we can name it with r. For the opposite side, we can write it equal to y and the hypotenuse r. So we get sine theta equals opposite over hypotenuse equals y over r. So that is the comparison of the sine ratio. The first is the sine comparison. Then the second comparison is the cosine or cos comparison. Our cosine abbreviation to cos. For writing, even though we call it with the letter K, when we write it with C or cosine, but when we mention it cos. Okay, for cosine has a comparison that is cos add hype. So generally an abbreviation like this is used, cos add hype. Cosine comparison is between the adjacent side and the hypotenuse side. So we can write cos theta equals adjacent side over hypotenuse side. Or to remind us, we can also write down for x for the adjacent side and r for the hypotenuse side.
Per sisi miring.
So we got cos theta equals adjacent side over hypotenuse side equals x over r.
Sisi samping. Nah, di y-nya merupakan sisi depan dan r-nya sisi miring. Baik, berarti di sini untuk cos theta sisi samping per sisi miring. Sisi samping nilainya merupakan nilai x dan sisi miring r. Jadi kita dapat.
Now that is the second comparison. Now we will proceed to the third comparison, namely, apart from having a sinus and cosine, there is also a tan or tangent, if abbreviated, so tan. Now for the tangent comparison, it is the ratio between the opposite side and the adjacent side. So we can write the comparison tan OAD equals to opposite side over adjacent side. Now, by comparison, the value on the opposite side is the y value and the adjacent side is the x value. So we got tangent theta equals opposite side over adjacent side equals y over x. Yep. So it's like that for trigonometry comparisons. There are three main ones, but there are three more, namely development and the opposite nature of the sine, cosine, and tangent values. Let's try the fourth one. This is the opposite of sine, that is cosecant, or here we can briefly CSC.
Sin kostan ini. Nah, yang keempat kita coba. Nah, yang keempat ini kebalikan dari atau inverse-nya dari sin, yaitu ada nilai kosekan. Kosekan atau di sini kita bisa singkat CSC. Nah, karena dia
Now, because the opposite of sine means that if the sine is opposite over hypotenuse, it means that the cosecant equals hypotenuse over opposite. If hypotenuse is r and the opposite side is y, so we got cosecant theta equals hypotenuse over opposite side equals r over y.
dengan mudah mengingatnya karena kebalikan dari perbandingan yang pertama. Baik, sisi miring itu r dan sisi depan itu y.
Yes, because the basis is the first three, sine, cosine, and tangent. For the other three comparisons, we can easily remember them because they are the opposite of the first comparison. Then the fifth after cosecant, there is also secant. We write our short to SEC or sec. The secant here is the opposite of the cosine, so that if the cosine is cos at hype, then the secant is sec hype add hypotenuse over adjacent side. So we find that the secant theta is equal to the hypotenuse over adjacent side, where the hypotenuse is r and the adjacent side is x. So we got secant theta equals hypotenuse over adjacent side equals r over x. Either the last one is cotangent or the abbreviated COT here is the opposite of tangent. So if the tangent is tan O at opposite over adjacent, then cotangent is adjacent over opposite. So cotangent theta equals adjacent over opposite equals x over y. So, like that, the ratio of each side is first sine, then cosine, tangent, cosecant, secant, and cotangent. Then we understand that in a trigonometry, there are some special angles. So, let's try to learn these special angles. So, there are trigonometry comparison at special angles. Now, for the first special angle, here we will write it first. There is a sign, so we make it like a table. So the first angle is 0 degrees. Now, for an angle of 0 degrees, the sine value is 0. Here we give the first line. Then we go to the cosine, which is 1. Then the tangent is 0.
Seperti tabel. Nah, sudut yang pertama ialah 0 derajat. Nah, untuk sudut 0 derajat, nilai sinnya ialah 0. Oke, sebentar, di sini kita beri garis. Oke, yang pertama sin, untuk nilai sin 0 derajat ialah 0. Kemudian kita ke cosnya. Nah, cosnya ialah 1. Kemudian tangan 0 derajat ialah 0.
Then the second special angle is 30 degrees. Now for a value of 30 degrees, sine 30 degrees, the value is 1/2. Then the cosine 30 degrees, the value is 1/2 times square root of 3. The value of tangent 30 degrees is 1/3 times square root of 3.
Selanjutnya ialah 45 derajat.
Then for the next angle is 45 degrees. The value of sine 45 degrees is 1/2 times square root of 2. For cosine, it is also special here because the values for sine and cosine at an angle of 45 degrees have the same value. So it is the same as 1/2 times square root of 2. Then for the tangent value at an angle of 45 degrees, the value is 1. Then at an angle of 60 degrees, the sine value is 1/2 times square root of 3. Then at cosine 60 degrees, the value is 1/2. And tan 60 degrees, the value is square root of 3. Now the last special angle is 90 degrees. For sine 90 degrees, the value is 1. For cosine 90 degrees, the value is 0. And for the tangent 90 degrees, the value is infinity. Okay, like that. So here we have a comparison of sine, cosine, and tangent at special angles. We can ask students to memorize them. It is quite easy to memorize. We can memorize it first to compare the sinus sequentially. The first is 0, 1/2, 1/2 times square root of 2, 1/2 times square root of 3, 1. Now for the cos value, it's just the opposite. So if, for example, sine 0 degrees to 90 degrees, the order is 0, 1/2. 1/2 times square root of 2, 1/2 times square root of 3, 1. So, for cosine, it means the opposite. 1, 1/2 times square root of 3, 1/2 times square root of 2, 1/2, 0. Because what is often used is the sine and cosine values, you can just memorize the sine value sequentially. Then for the reverse, that's the cosine value. So, for the trigonometric comparisons, we have learned about sine, cosine, tangent, cosecant, secant, and cotangent. We have also learned the values of trigonometric ratios at special angles. Thank you.